Hello, good afternoon. Um, I'd like to talk about the water supply, the drawing during this session of the screen capture video. Um, Previously, we have done the calculations, okay, the calculations of um, the water supply, the um, the in, the, the input, and and later on we look at the pressure, the loss, the head loss, and then later on we check um, the the water supply, the 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 pressure at the various knots, and then we check that, make sure that is still sufficient at the at all the knots, okay, as specified by water K. So I'm not going to look at the calculation this um, during this session, okay, but just to do um, the drawing, the layout drawing only. Okay, so we will not be doing the long section because because we just look at we just use the plan, and then because we just follow the road level, just um, the water pipe is just about 0.6 meter um, below um, below the water. This is the water level. Okay, the water pipe is just zero point 0.6 to 1 meter below the ground. Okay, so this um this waterman um has to be is have to be at the berm area within this from um the road reserve area. So from the away from the carriageway, and then towards the in between the property boundary and the carriageway. Okay, so I think up to based on the water K. Okay, so so the location. Let me see so this the locations. So it will not be in the waterman shall only be installed in public road reserve. Okay, public watermans in private property, right of way and private road is not permitted. So we're not going to put um, the waterman under the rods only for during the crossing. Okay, normally for tapping purposes, they will be on the at the between between the carriageway and the boundary to private property. Okay, so we'll be looking at using both the principal and rider mans. Okay, so for the main rod, we will need to use the 100 mm diameter. I think we have followed, we have designed it. So actually, so we will be using the 100 meter internal diameter the watermans. Okay, so and for the jaw, we'll be going to use the 50 mm the rider mans. So okay, and then we have to put the hydrant as well. Hydrant need to be put at the 100 mm, at least 100 mm rider mans. Sorry, the principal waterman. So we the spacing of the fire hydrant have to be 135 at least, not more than 135. Okay, based on the SNZ PAS 4509. Okay, so the the spacing is have to be um, not more than 135, not more than 135. Okay, so um, require water flow within a distance of 135. Okay, for the fire hydrants. Yeah, I think yeah, the design part we have looked at it already. I think we have using the like 12.5 liter per second. Okay. Okay. So the calculations in the calculations, um, we we use the alternative scheme. So this is different from yours. So we need to put the water pipes. This is just the during the design stage we just put the pipe anyhow. So um, along the draw one, and then the rod two, and then the draw two as well. We need to put a pipe, one water pipe down here, and then we tap it from the 250 PE. Okay, the material that we're going to use, um, in this case, we have a choice of like UPPVC or PE. I think we would just use the UPVC. Okay, at this stage. So we have done the design, and then we come up with the pipe size. Um, for this the pipe, the main pipe going down 1 2 3 6 1 2 pipe 1 2 pipe 2 4 and pipe 4 6. They are all using the 100 mm diameter, and for the branch, we use 50 mm diameter, the rider mans, and 50 mm diameter 50 mm. But because we this one, the riderman, they need to serve only like the lots fronting the riderman. But this one we have to, for this lot 2, we need to serve the other side as well. So for lot 2, this um we need to serve both the lots 5 6 to 10 and lots 11 to 15. So I even though we design it for like 50, I'm going to increase the size to 100, so to cater for both direction, both side of the rod. So we for the calculation part, I think you just refer to the the previous the screen capture video on this. Okay. So this layout plan, we already have put in the stormwater pipes. Stormwater pipe, the like this 450, 450, and then 375, 375, 375 stormwater pipes. And then we also have put in the the wastewater pipes, or the sewer line. So this one we use a 150 UPVC. 150 UPVC, and then we discharge it into the existing manhole here. So we need to put in um, this waterman, the principal waterman, along um, the rod, along rod one, this rod one, and then um, the dual one, I'm going to put the 50 mm UPVC rider mans, and then rod two, even though we design, I think with calculations we said that 50 mm is sufficient, but I'm going to use the 100 mm UPVC, so that it can tap it from both side of the rod, and for the jaw too as well. Okay, I'm going to use a 50 mm UPVC pipes, and then I'm going to uh, provide two fire hydrants. One somewhere here, because the fire hydrant need to be the spacing not more than 135. Because this dual one is about, I think, about 90 meter, at least 90 meter. So I need to cover the fire hydrant need to cover at least 150 meter, 130 meter from from the furthest point. So I need to put one here. Okay, so somewhere here at the side of lot 6, and then another one probably just down here at the bottom here, because here I could put it here as well. I think I just put it here. So this will cover everything. Okay, you will cover the fire hydrant. You will cover the distance in case of fire for this draw 2 and further up, and then it's the spacing from this for the next fire hydrant is about, I think, less than 135, and then this the fire hydrant here you cover the rod 2 and then draw 1 as well. Okay, so I will need to draw the pipes. Actually I've done something up there, but I'm going to redo again. So I've done some of the pipes, and then I'm going, yeah, so I need to do the pipes and then the fitting as well. Fitting, that means the fire hydrants, the valve, the valves, and then the different type of valves. The Swiss valve for the principal man, 100 mm principal man. For the rider man, it's called a pit valve. Okay, when the when the um, when the diameter is smaller, then we use a pit valve. Gate. Sometimes it's called a gate valve. So for the principal man, we use a sluice valve, and the pit valve for the TMM, um, the rider man. And the fire hydrant will be placed on the 100 mm principal valve, and the end cap will be placed at the end of the water pipes. So it will be at the end of the like 50 principal man and as well as the rider man. Okay, so I use the dash times 2 line. Dash times 2 line. I'm not going. This time I change to from the continuous line before for the stormwater pipes and the wastewater pipe. So this one I use a dash. This line type is dash times 2. So to differentiate the size, I will just label it like 100 mm, and rider man is 50 mm UPVC. Okay, so my layer at the moment is, I think, is project water supply, and then blue, and then dash, I think dash times 2. Okay, and I do a line width of 0.3 meter. Okay, 0.3 meter. So and then to show the line width, you need to display the line width. You need to display it under the format, um, format and line width. The default is 0.25. If it's 0.3, then you will show it. If it's less than, if it is 0.25 and less, it will not show any line width. Okay, so I can either do a P line or the line. P line, I will do a P line, polyline. So I start from this. This is the waterman, the 250 PE. This is the water. The this is the waterman. Okay, so I just do the step it from here. I want to do here. I want to do it between the this is the stormwater pipe 450 mm PE, and then the boundary, the lot boundary. I want to put something in between, but I have to cross the rod as well. So the pipe will need to cross the rod. So yeah, so it could sometimes it could have protection, the pipes, the PV. If it's steel pipe, it's okay. Steel pipe, then it be strong enough. But sometimes PVC, you need to have inside trench, you need a protection on top. Sometimes you just to maybe different way to protect it, to compact it, the material, and then you sometimes you even put concrete cover on top of it. So I just draw it all the way down. I'm going to, yeah, so some way in between um in between this stormwater pipes and then the boundary. So I'm going to put it here. Yeah. I think I'm going to put it down all the way about here. I don't need to go to the end. I just stop here. I put an end cap. Okay, so I do the same for the other side. I will need to put there's a space here. I need to put it between the stormwater pipe and the property as well. I just put I think I do a P line. Um, I will do it here. Okay. So with the water pipe, we don't need to put any manhole when there is when um when there's a change of direction, because the water pipe usually they have a fittings like uh for like 22.5 and 45 degree the bends, and then I think 90 degrees bend as well. So we don't need to put any manhole when there's a change of direction or change of grade. So the fitting will do. Okay, so but we need to provide a lot of valves because um, sometimes there's a water leakage, and then we need to shut the valve to so so that the water can that section that need that need to be repaired, the leakage, and then need to be replaced. We shut the two valve, and then we just repair the part that is broken. This is not a this this water this network is not very good because the loop one is better, because the loop one, if you shut the valve somewhere, you can stop a localized leakage, and then the water still can go around from the other direction. The loop, because a loop, it can go um, from the other direction, the other line, because the thing is everything is loop in a loop. So you shut it off, but the water can go around from the other direction. So this one is a tree branch. It's a branch the network. So if you shut it off here, then shut it off here, for example, then all the water pipes down here, there's no water. Only you shut it off, let's say here, then the water pipes, only this one, the one fronting the lot 1 to 5, you can have put a valve. Somewhere is leaking. So we just shut off this valve here, the water will not go through. But this is the branch network. It only allows the lot 1 to 5 to use water, and the rest you have no water. So that's not that good for this branch network. Okay, so this one I think I need to do it here. I want to do it somewhere here. Um, Turn off this snap. Oops. Let me try again. P line. Okay. Let's put the line at the end. Okay. Yeah. So this is the main line. The main part. I'm going to use UPVC UPVC pipes. Okay. So I'm going to put the valve. The valve. I'm going to actually drawn something here. Up here, just going to probably I just copy the legend. Okay, so these are the legend for the sluice valve, the pit valve, the fire hydrants, and the blank cap, all these things. So basically, you just probably you just you do it to size not too big, not too small. I think there's no. I think I didn't see any like standard of the dimension of to the valve. So I think you just you make sure that it's symmetrical. The symbol for sluice valve, and then it's a circle, and then the fire hydrant you do something like this. It's about four equals segment, and then this is a blank cap. That's a blank cap. So this is a symbol for blank cap, and then I just use a dash time two. That's dash time two lines for this, and so I want to put the um Swiss valve. A Swiss valve will be um, I'm going to put the water copy the waterman. I think this one will be the middle of the this one is going to be 100. Top one will be 50. I'm going to change it later on. This one is going to be 50 as well. The draw 2. So draw 2 going to 50, and then the rod 2 I'm going to keep it as 100, and then the draw 1 I'm going to change to 50. So I copy. I need to label the pipe for the for the along the pipes along the rod 1 as well. I'm going to rotate this 90 degrees. 90. So I'm going to copy. So just somewhere there, and then the next one as well. And the one in the down here as well. So this will be 100 mm UPVC pipe. I'm not going to I just delete that. So now I'm going to so I have named all the pipe lines, pipe lines. So I need to put the sluice valve as well. Let's copy. Let's put it, okay. And I need to, for the 100 mm, I can put a sluice valve. Let's put it here. Okay. I need to trim it. TRIM trim. Copy this sluice valve to the top as well. And because I'm going to put along this pipe, the pipe the along the rod 1. So I'm going to rotate this as 290 degrees. 90. Yes, okay. I think I just move it. I'm going to put the SV here to the other side. Okay, so I'm copy. I need to put one here so that if there's any leakage, I can stop here. I need to put one here down here as well, because if there is any leaking down here, then I can just close it, and then this the pipe to the draw one still can be using. Okay, I don't need to do another one. At first, actually, I thought need to do another one here, but because we don't have any loop, so it doesn't make any difference. So if there's a loop, probably I could let's say if the pipelines across the road is broken, I can just put a switch valve. I can just stop these two. These are two sides. Stop it. The water can, and then can just replace the rod. But here with the tree branch or the um, probably no meaning to put another valve here because I'm going to put down here one valve, and then it will just be a longer section. Okay, so I got a valve here as well. So the if there's anything like leaking, then I can just stop this valve up here and these two switch valve, and I can like just do the repair. So I'm not going to put another valve here. So because of this there's no loop. So I'm going to put another switch valve down here. Okay, I can trim it. TRIM trim. Let's trim this one. Switch valve. Just that to I think it's you trim it looks better. If you don't trim it off, it's oops, it looks a bit the untidy. So I just okay, that's a switch valve. I don't need this anymore. I just cancel it, erase it. Need to grab hold of this the pit valve as well. Copy. Oops. Copy. Grab the middle. So I put one here. Later I need to shift the PV so that it doesn't interfere with the MH3. I need to put one at the here as well, almost the end. Okay, I put this on the blank cap at the end as well. Okay, so because we most of the pipe, the open pipe, we need to put a blank cap so to so that the thing is protected, so nothing can go inside the earth material or whatever insect or whatever. So this need to be we need to keep it close, the water pipes. Oh, actually I need to put the switch valve at the end. Need to put I put it here because I going to this part I still going to keep it as 100. I'm going to put the fire hydrant here, so fire hydrant will be here. So I just I move it further down, and I could need to put one here. Okay, so I trim it. Trim. Trim that. Okay, so there's a switch valve, and then the pit valve. So I need to move the PV to some, so it's not blocking. Just turn this off. PV. Okay. Same thing I do for this PV. Move the letter, the word PV. Let's say here. Okay. I need to do the the blank cap as well. Copy this blank cap. Okay, it need to be the other direction. Okay, because the this thing here need to this triangle need to be the other side. So I just rotate it. Rotate 180. Okay, so so I just copy this, take at the intersection. Okay, Okay, that's it. And then here as well. I need to move the PC, the word PC later on. BC, not PC. Okay, this. Okay, so this okay. This one the BC. I need to move it. Maybe. Yeah, I think it's okay. Here it's okay. Um, this one. I think this one need to move it up. Move. I could move it here. Okay, I think they need a source file here as well. Copy at the end. I think it have to be here because there's no line. The middle there's no line. Oh, here. Okay. Trim. I need to copy the word SV as well. Okay. So these are the layout with the pipes and then all the fittings. Okay, so yeah, I think this is SV. I just move it some way. Okay, so I don't want to it's clear so that it doesn't put the word in the symbol doesn't um overlay with the lines or whatever. Okay, so that's about that for the what this this one water supply layout. I think it's about the same as the one. Yeah. Okay, only thing is that I think I made a mistake here. I need to change it. This one, the 100 mm, rather than PV, you need to be SV. Okay, so the actually this one need to be changed. PV here and the PV here need to be changed to SV. Okay, I think I still need the I still need to put the fire hydrant. Okay, the fire hydrant I need to put one here because I don't need to put it up there because the distance is 135. So 135 if I put here, then it will cover it will be within 135 from here. This one is about 90 or 90, and then up here should be less than 135. And then this 500 will cover this drawer one and rod two. And then but this 500 will not be able to cover drawer two. So I need to put another 500 down here. I could put it up there as well. Or if I put it up there, then I would need to move the switch valve. Um, Actually, I don't need to put a switch valve here. There's there's no need because um yeah, okay, maybe I don't need because there's a valve here. Okay, so just like this one, um yeah, some of the things that actually I didn't put in, like they have the reducer, the valve reducer. So when you join the 100 mm to 50 mm pipes, you need to have a reducer to to do it. So actually I didn't put it because actually there are quite a lot of things I didn't put in as well. When the pipes change direction, you need to have a bend, like this one's 90 degrees. Some of them is, for example, this one, it could be 45 for the chain. And then they have anchor block as well. So normally we don't, they are in the fittings, in the details for the water supply. So the details of the fittings. So even the fire hydrant as well. So they got the detailed drawings. So some of the thing and we cannot specify everything. Okay, so even though um like every lots there we have to put the connecting line going in, and there's end cap. I think we put in going in like But so it's understood that I think the contractor, when they will put at least one connecting line to each of the lots. Okay, so I just copy the fire hydrant. Oops, I try again. Copy. I need to grab the center. I will put the fire hydrant somewhere here, and then another fire hydrant here. Okay. So I just move the FH fire hydrant. This later I just move it to the side. Okay. So a lot of things like the water care, they will mark the fire hydrant position of fire hydrant as well. So but here the what I don't do that. We don't do that because it's too many details. I just trim it. So these are the legend for the fire hydrant. Okay, this one that's a meter. Cannot see. Okay, so that's how to do the layout for the uh for the waterman. Okay, so for the waterman, for the water supply, we don't need to do the long section because all the pipes will be, the plan will be like this. The depth of it will be just 0.6 to 1 meter deep. Okay, so we follow follow the guidelines. We just because I think some of the, actually I saw some of the places, actually the water supply line actually go inside the private property. Okay, but sometimes you can put a valve in the middle of the road as well. I think uh, it can sometimes is it can carry the, it can stand the, this one, the chamber of the sluice valve. It can stand the traffic loading. Okay, but I just now I saw the like the water care, the requirements. So everything just put between the private property and the carriageway. So I just try to, okay, just do that. But there could be some, I think, exception. You can sometimes if there's no space, you could put the water supply line in the private property. Okay, just near to the edge. Okay, so we don't need to do the long section, so it's easier. Com so the rods, you need to do cross section, the long section for each of the like for this scheme is the rod one, the jaw one, rod two, and then jaw two. You need to do the long section. For the stormwater pipe, you need to do the different long sections as well. And for the wastewater pipe, you need to do the long section along the sewer line. So the sewer line is like this on 150 UPVC. You need to do um there are three lines, like here there's one, and then here another one, and then the bottom here there's one going this way and up there up to this line. So in, only the water supply, you don't need to do the long section. And actually for all the different type of whether water supply, wastewater, um, stormwater, you need to provide the details as well. Details of fittings for the um, like the manhole. Okay, so for this one, the water supply is a bit is different from the wastewater, because the water supply, the drinking water is very clean. You don't need to provide any the the gradient, the gravity, because actually there's the the pressure there already, pressure this existing water supply, the water pipe, they already have certain pressure in terms of like how many atmosphere, um one atmosphere is about 10 meter. So this one about, it could be go up to um 30 meter high, which is 3 atmosphere. Okay, so and then the pipes, it is designed, it can sustain like this one, the PN 12, PN 16. That means it can sustain 12 atmosphere, which is 120 meter. 16 PN 16 it can sustain 16 um, atmosphere or 160 meter. So the PVC, I think there's also something they designed for, I think this PN PN PN12 at least can withstand like 12 atmosphere or 120 meter pressure. So yeah, so this the drawing, the layout drawing for the waterman. Okay, I think I will stop here now. Thank you.